So everyone, welcome back. We are here for problem 3, where we have a new type of interest called continuous compounding. Continuous compounding is a different formula than what we would use for compounded monthly, but we're not going to talk about that in chapter 5. We're going to talk a lot more about that in chapter 6. So we'll just roll with this problem the way it is since we're already provided the formula. So we see if P dollars is invested for X years at 10% compounded continuously, the future value of the investment is given by this right here. There's a lot of variables there, and I need you to understand that E is not a variable. E is actually a number, like the letter, like the number pi is 3.14. We represent it with the symbol. E is a number that we just represent with the symbol as well. So we need to use P as 1,000. So the initial value there, or the amount that was invested into this fund was $1,000. That's going to go in place of P, just like I have here in my iPad. And we're going to go ahead and give that to GeoGebra. We are asked to describe what happens to the value of the investment from 0 to 20. It looks like years. And so S equals 1,000 times E to the power of 0.1. And in the case of GeoGebra, everyone, if we put N in there, it would do bad things. We want to put in X. And so GeoGebra likes X's and Y's. It doesn't necessarily like other variables quite as much. So again, I'm holding down Shift and pulling on this axis to be able to move these to be the way that I want them. And so I have from, let's see, 0 to 20 years is the first one I'm looking at. We can see that the slope down here is very flat. And as time goes on, it increases, and it increases even more, and it increases even more. And so it looks like in our case here, everyone, in about 20 years, if I was to guess, I would say that that value is right around $7,450. Now I can use Wolfram to find that value exactly, and I've already put the information into Wolfram, and one thing I want to draw attention to is I did it wrong. So you'll see here that this 0.1 is not being multiplied by 20 in the exponent place. These 20 got brought down here. And so that's why I'm getting a totally different answer. Instead of 7,000 and something, I'm getting 22,000 and something. In the case of this, everyone, what we need to do is put the stuff that's being raised to the power of the exponent in parentheses, and that will fix that problem. It will keep that 0.1 and that 20 together up here in the exponent spot. And now this number that we got here matches very closely with what we got in GeoGebra. My guess on GeoGebra was 7,450. The Wolfram number is 73,000 or $7,389. So for part A, the investment, I'm going to move my iPad up here a bit. Grows faster over time. And reaches a value of 7,389.05 in 20 years. So 06, not 05. I did a bad job rounding there. So the other piece, everyone, and it's interesting, you would think that compounding continuously would be better than monthly compounding. We could, and we will, in chapter 6, be comparing the results of compounding continuously to compounding monthly. But to me, it doesn't seem great that this investment only gained that much money over 20 years. Let's take a look at what happens to this investment from 20 to 40 years. And so if we bounce back to GeoGebra, we bounce back over to GeoGebra, we can use our Shift and grab the axis key, or the axis tool, in order to pull ourselves over to between 20 and 40 years. So we see 40 years is way up here. And so I'm going to grab this axis and pull it down to where I get my graph meeting the vertical line at 40. And we can see we gained only about $6,000 from here to here, which is not super awesome. Looking from 20 to 40, though, we can see it went up a huge amount, and it's much steeper over here by 40. Let's drop another point and take a look at what's going to happen in the time between 20 and 40 years. So it jumped to almost $55,000. That's pretty incredible. So we gained about $48,000 over the next 20 years. And so it was kind of slow getting going. The first 20 years, we only gained about $6,000. The next 20 years, we gained about $48,000, something in there. That's pretty insane. So continuous compounding it looks like one of these that really benefits from being fed a lot of time. So huge growth in this 20-year period, not so great growth in this 20-year period. And so how can we use this information to build wealth for ourselves and wealth for generations? Let's go ahead and use Wolfram first to figure out exactly how much is going to be in that account after 40 years. And after 40 years, the value of the investment grows to be $54,598.15. And so we can see that the question there is, how do we use this information to build wealth for ourselves and wealth for generations? The answer there is sort of duh. We feed time money and it grows faster. So for the rest of part B, feed time to money and watch it grow. And so again, it's important to understand the older an investment is, the faster it grows. And so you can legitimately leave a huge amount of wealth to your grandchildren or great grandchildren by establishing a fund today with like $50 and just letting it grow ridiculously over time. I will teach you how to do that in chapter 6.